Today is Monday, August 1st, 2022. It is also day 379 of data science. And today I'm going to do another normal distribution problem, but the difference is that I'm going to do area between 2 points rather than what I've been doing before, which is area below or above a point. Now, I don't even remember if I've done this before. I think I did it once maybe, or I looked at it once with Python. It's super easy to do in the calculator. So I'll be doing it with Python, TI-83, and the TI-84. But I guess I'm going to struggle a little bit with Python. So I'm trying to think. So first things first, normal distribution, I need the normal CDF function. So I'll import that from scipy.stats norm. So norm in Python is the equivalent to normal CDF if I could just spell it right. All right. So I'll do norm.cdf, and what I think I'm going to do is, because a normal distribution, like the sum of it is 1, right? So what I'll do is I'll get the area or the proportion below 170.5 centimeters, and then I'll get the proportion above 180.3, add those two proportions together, and then subtract that from 1 to get the space in the middle. So I'll do that. So in normal CDF, there's 3 parameters. So it's x, the log, which is the mean, and then the scale, which is the standard deviation. So scale is 10, right? It's 10 centimeters. The mean is 170.4, and then the x I like to define as the point that I'm trying to find the area or the proportion below or above it. So in this case, it's going to be 170.5. It's actually both 180 also, 180.3. So I'll just do 2 of them, right? And just change this to 180.3, and the only difference I'm going to do is for this one I'll do SF, right? SF is the equivalent as 1 minus CDF, so it's going to give me the area or the proportion above 180.3 centimeters, so that's to the right of it, and then CDF just calculates the area below 170.5, the point of interest, which is x, right? So this is only in Python, by the way. So I'll get those answers, and I'll set it equal to left, and I'll set this one equal, to right. Hopefully I won't round it so it could be as accurate as possible, and I'll just do the sum, set it equal to left plus right. And so I'll print out the sum so I could see what it is. So that's the total proportion, and so I'll just do 1 minus the sum, and I believe that's going to be my answer. And if I round that to 4 decimal places, actually I'll set it equal to a variable. So I'll do answer is equal to 1 minus sum, and then I'll just round the answer to 4 decimal places. And then let's see if that's correct. If not, then oh well. Oh my god! Yay! Okay, so that's exciting. Okay, so that was the hard part. Now let's get on to the easy part, because it's easier if I do it on the calculator. First though, I want to kind of make a graph to kind of visualize what I just did here. So for this, I'll have to import matplotlib.pyplot, which is a graphing library, and I'll also import numpy, so that's going to get me it's going to help me get my x values. So in a graph, you have x values and you have y values, right? So in a normal distribution, your x values can pretty much be anything that's surrounding your mean. And so if I know that my mean, my average, is 170.4 centimeters, then I'm just going to have to use this function linspace that takes in 3 values. So it takes in starting point, ending point, and how many points or values in between. So if again I know that my mean is 170.4, then maybe I want to go and do something like 100 to start, and then maybe something like 200 to end, and then have like 1,000 values in between. Now those are going to be my x values, and so for my y values, because this is a normal distribution, I want to be able to find the density of each of the x values. And so in order to do that, I'll do norm.pdf, which is the probability density function, which calculates the density for a specific point. In this case, it's going to calculate the density for all of the x values, with the log, again, the mean being 170.4, and the scale being 10. And then Again, difference between PDF and CDF is that PDF calculates the density for a certain point. So again, if I were to do PDF, norm.pdf for like 2, whatever, like a value 2, it would calculate the density or the proportion exactly at 2. Where if I were to do norm.cdf for the value of 2, then it would calculate the cumulative density up until 2, so that includes the density of 1. Anyway, just wanted to mention that. So now to plot it, I'll just do plt, right, which comes from matplotlib, which is a graphing library, and I'll do plot function, and I'll just plot the x values and the y values and see what that looks like. And it might not be perfect, right? So it's not perfect, it's a little bit skewed to the left. So that means I could either kind of increase this to 300 or 250 and kind of play around with that until it kind of looks like a normal distribution, right? So maybe I'll do 150. Nope, that's really bad. 200? Nope. No, let me go back to how it was because now it's just like not looking good at all. 250. All right, that looks good. And then I like to add a title. So plt.title, I'm gonna call it normal distribution of college students' heights. College students' heights with the mu and the sigma being their respective values. So mu symbol. So we're just gonna grab that there. Where's my stuff? Okay. Mu equals to 170.4. And then let me grab the sigma symbol. In stats. All right, let me go back. And sigma was 10. Now if I run that, I'm going to be able to see that. I might as well just kind of put a break in there by doing a /n. Okay, nice. So now I also like to do a y label and set that equal to density or proportion, whatever you want. And then plt.x label, set that equal to height, because that's what we're measuring. And I believe we're measuring in centimeters, so let me put those units in there. All right, so that's my graph. Now what I'm going to do is I'm just going to copy it. I'm going to go to my whiteboard, and I'm just going to do the math by hand. And by hand, I mean with, as much, like as long, I can't even speak, as handy as I could get, because at the end of the day, you still have to use a calculator to get the answer. So let me paste that in there. All right, so for me, let me lock that in. So the question was, I believe they wanted the proportion of students' heights that are between 170.5 centimeters and 180.3 centimeters. So 170 would have been 170 over here, something like that, and then 180.3 would be over here. So they basically wanted that proportion in between over here. That proportion of college students whose height is between 170 whatever centimeters and 180.3 centimeters. And so that's the proportion they wanted. But in Python, I couldn't get this. I mean, I don't know. I'm not aware if there's a function yet. I haven't researched into it that does a value like in between. But for me, so far with my knowledge, I know that I just know of CDF, right? And then also SF, which is the opposite of CDF. So what I was thinking, okay, if the sum of the area under this curve is equal to 1, then I could just get the area to the left of this point, right? And then the area to the right of this point, and then add those together, and then subtract that answer from 1, and that's going to give me the pink area. And that's exactly what I did. So again, I don't know if I want to, maybe I do want to do that. Okay, so I could actually figure out what that was. To the left was that, the right was that. So the area to the left, let me actually do different colors. So the area to the left was the area in the yellow, right? and that was 0.5. So that was 0.50, kind of like 40, right, rounded. And then the area to the right, right, that area ended up being 0.161, rounded. And then what I did was I just added those areas. So I did 0.5040 plus 0.161. That gave me, what did it give me? Let me go back up. Answer. That gave me 0.3349, and then I just took that and did 1 minus 0.3349. Oh, actually, no, that's not what it gave me. Hold on. No, that's actually the actual stuff. It gave me, what did it give me? 0.6 something. 66651, and then I did 1 minus 0.6651, and that gave me 0.3349, and that was this area right here, 0.3349. All right, so let me color code that because I love color coding. So that's this, this is pink area, this is the yellow area, oops, this is this. Actually, let me go back. I made a mistake. This is this. All right, this is the pink area. This is the yellow area. Right, and then this is just the answer. And then 1 is the whole thing. It's literally the whole thing. How would I? Maybe glitter? Should I use glitter? It's the whole thing. That's how I'm representing the whole thing. All right, that's 1. Okay. So that's the whole thing. That's what I did in Python, and yep, that's pretty much it. Now by hand is a different story, and it's kind of easier. So if you're using a TI-83, I'm using a TI-83 because that's the only calculator I have. I just happen to remember how to use a TI-84 because it was just a function that I use literally every day during my stat class. And I borrowed my teacher's TI-84, so yeah. Okay, so for a TI-83, you go to second, vars, 2 to get the CDF, normal CDF function. So it's going to end up being normal CDF, and it's not going to give you anything. It's literally this. This is what appears in your calculator after you click on this. So you're just going to have to know what to put in there. And so I'll tell you what to put in there. So the values are lower bound, upper bound, mu, which is your mean, and then sigma, which is your standard deviation. Now, here's why it's so much easier in your calculator, because it's saying, the question is what proportion of students' heights are between 170.5 centimeters and 180.3 centimeters. And so they're literally giving you your lower bound and upper bound. So it's, your lower bound is going to be 170.5, your upper bound is 180.3, your mu, which is your mean, is 170.4, and your sigma, which is your standard deviation, is 10. And then you click enter, and it should give you, right, 0.3349, and that's your answer, right? And that's what's pretty cool about the calculators, that they treat the lower bound and the upper bound as intervals, right? The interval in which you want to find the proportion or the area in between 2 points, in this case, are those. So that's it for the TI-83. And then for the TI-84, let me go here. For the TI-84, it's the same access method. So second vars 2, that's the equivalent of norm.cdf in Python. So it's normal CDF, and it doesn't, I'm not even sure if it says it. Anyway, what I remember though is that it presents to you the following options. So it's literally like this: lower, upper, mu, and then sigma. This is what it looks like in your calculator. Let me see if I could draw kind of like a box. That's a horrible box. Okay, this is gonna take a while. Okay, pretty. All right, so, and then you would just put in your values. So again, your lower would be 170.5, your upper would be 180.3, your mean 170.4, and then your scale, not your scale, your standard deviation, which is the equivalent to the scale in Python, would be 10. And then, whoops, I made the box a little too small. I need it to be, hello? All right, we're just gonna pretend it's that. And then at the bottom, there is this paste sign that when you hover over it, it turns black. And when you hover over it, press enter, and it should give you 0.33. What was the answer again? 49? Yeah. And yeah, that's the answer. And that's all there is to it. Let me go ahead and color code. I have to color code. All right, and then let me see. Color code, so pretty. Yeah, and then I could also, let me think, should I do this using these scores? So like in College Board, what I did right now is called calculator speak, and it's not enough to show that you know your answer. In College Board, you would have to use z-scores and like to show the conversion factor with z-scores instead of using, you know, the straight up like values that they give you. So I would have had to convert 170.5 into a z-score. Actually, I'll do that. Why not? Okay, so I'll do that. Let me do that real quick. So for z-scores, the equation for z-scores is that z is equal to the point minus the mu divided by sigma. So it would kind of have to had been the same like thinking process that I did in Python, because I would have had to do actually no, I take that back. No, because all I have to do is plug it in. Okay, you'll see in a second. So I'll just basically take my first x. So in this case, let me give it a color like you know what? Let me not do that. So I would just have done 170.5 minus, what's the mu? What's the mu? 170.4. Divide that by 10 for the first one, and that would have been 70.4 divided by 10, 0.01. And then for the second one, it would have been, what's the second one? 180 minus 170.4 divided by 10. Oh, it's 180.3. Not me almost messing up. 180.3, not 180. Okay, I can't even speak. 170.4 divided by 10. Whoa. Ooh, I did 3 times 170. What the heck? 180.3 minus 170.4 divided by 10. That's 0.99. And so then what I would have had to do is use a standard normal graph, which I can plot real quick. So let me do that. The standard normal graph would literally be this, but with the mean of 0 and a standard deviation of, what do you call it? Of 1. So this would have just been 1, and this would have been 0. And then obviously I would have to adjust the scale, so -3. Not the scale, but, well, yeah, technically the scale, kind of like the x, the domain of the x. All right, and then that would have been the standard normal distribution. I would have to change this also, so it's relative. So this would be the standard normal distribution. It's not specifically of college students' heights because this is the standard normal distribution of anything. But I just converted it. So this is basically the graph now. So let me go back to my whiteboard and paste that in there. So the graph essentially looks like this. All right, so Let me lock that in there. It's not locking. Okay. Is there any way that I could just make all of this smaller? Are you serious right now? Don't mind me. Oh my god, this is a mess. Never mind, I'll just continue. All right, so back to this. So this is a standard normal, right? So basically now the points are going to be 0.01 and 0.99. So that's within 1. So 0.99 would be around here and 0.01 would be around here. So it's literally the same visually. If you put the two graphs on top of each other, it looks the same, but it's just different values. But they're equivalent though. So it's the same thing. That's the area that I'm trying to find, right? And so what I would do is if I were to use the z-scores for the TI-83, the z-score, I would have to use a standard normal distribution. So that would be normal CDF, and I would have had to do 0.01. Upper bound would have been 0.99, and then 0 and then 1, right, for lower bound, upper bound, mu, and then sigma. And then for the TI-84, whoops, why can I not spell? Scores. That is so sloppy. All right, it would have been lower, 0.01, upper, 0.99, mu, that's a horrible mu 0, this 1, and then paste enter whatever, it would have given you 0.3349, and then 0.33, hello, and that's it. All right, so let me just do that. All right, and that's literally it. Is there anything else that I want to say? I don't think so. Just double checking really quickly in my calculator that I did this right. 10. Yep, I did it right. Okay, it works on my TI-83. Using, everything that I did. All right, so that's it for today. That's using z-scores with a standard normal distribution, which is kind of the way that College Board wants you to do. So kind of like in a summary, right, College Board, to answer these types of questions, you would have to draw out the graph, label it using a capital N, mention your mu, your sigma. So in this case, it would have been 170.410, like that. And if you don't do a capital N, they don't count it. All right, and then you would have to show, that's 1. Then you would have to show your z-score conversion. So that's this stuff. And then you would have had to do, your standard normal distribution, and then the answer, I believe, is the third point. But I don't know if there's something else that I'm missing that you have to show, but at the end of the day, this is the answer and it's correct, but I don't know, College Board always wants something else. But yeah, okay, so yeah, that's pretty much it for today. Bye.